Hello everyone. In this video, I am going to discuss about the concurrency control. So concurrent execution is nothing but in particular schedule, multiple transactions are executing simultaneously with their interleaved operations. That is, by cooperating multiple transactions, they will be performing the execution. At that time, there are certain problems can be noticed. That is a lost update, dirty read, and unrepeatable read. These are the common problems which are occurred in the concurrent execution. But we need to avoid these problems as much as possible. And here we have by avoiding these problems, when the concurrent execution it is taking, we need to maintain some of the desired properties in the executing transactions. So here we have a desirable properties that is atomicity, acid properties, atomicity, consistency, isolation, durability. So by maintaining these, by ensuring these properties, by avoiding these problems, we need to maintain the overall execution of the concurrent execution of the transactions in the smooth way. That is concurrency control. It is one of the technique here. It is one of the concept that is required for controlling and managing the concurrent execution of the database operations. So it is having two objectives here. In order to control and manage the concurrent execution, it is required to ensure the desirable properties, ACID properties, and it is required to minimize the problems, concurrency related problems, these problems. These are the basic objective of the concurrency control. So in order to maintain the concurrency control, we have two basic protocols here. One is a log-based, another is a timestamp-based protocol. So first we have to go for the log-based protocol. Log-based, here we have a log in the sense, suppose multiple transactions are performing the operation on the particular data, particular resource. That data, it will be logged. Means here it is having some restriction. When that data it is using with one of the transaction, whether it is allowed to use for the other transaction, or if it is allowed, for what type of the transaction it is allowed, that these restrictions are called as a log here. So here we have two types of the log. One is a shared log, another is a exclusive log. So here major operations of these transactions will be considered two here. For simplicity, we are considering only two operations, that is read as well as write. So read operation, when the read operation it is performing, there is no any change it will be occurred in the data of the database. Data of the database cannot be changed in read operation, only for the reading purpose it is. Whereas write operation, it is going to access and modify the data of the database. So here we have two operations. So in this we have a shared log as well as exclusive log. Two types of the logs. Based on these operations we need to implement. So when any of the transaction it is performing the read operation, then any number of other transactions also can go for the reading. So here reading only retrieval of the data, and it will be accessing with the multiple operations only for the reading purpose. It is not going to do any changes in the database value. That's what multiple operations are allowed here. Whereas a write operation, it will be modifying the data of the database. When the modification it is required, then requirement of the processor action it will be taking place. Only one processor in the computer system, so it can go for one task at a time. So when it is required to write, in this we have a exclusive operation it is required here. Means any of the transaction, it will be performing the write operation on particular data, then no other write or read it is allowed. So here we have a shared log, it is applicable for the read operation, whereas exclusive log, it will be applicable for the write operation. Means the transaction which it will be performing the read operation on the data, that data it will be taking the shared log. If the transaction it will be accessing the data for the writing purpose, then it will be taking the exclusive log. This is the indication that if any of the transaction it is performing the read operation, then any number of other other transactions for the reading purpose, it is allowed. Only they are reading the data. Suppose, for example, we have a data A here. The data A, it will be reading by one of the transaction T1. Then other transactions, T2 also it is coming for the reading purpose itself. That already it is allocated with the lock, shared lock. Means now it will be sharing. It will be sharing with the other transactions. That read operation, it will be sharing with the multiple transactions for the same purpose. That here T2 it will be reading and T3, T4, any number of read operations we can take here. And that only here after by unlock only it has to go for the write. But when it is reading, only reading simultaneous it is allowed. But when it comes to writing, first it is required to unlock and then only the write operation it is allowed. Means no other write operation it is allowed when of the transaction, one of the transaction it will be reading the data. So only read multiple operations are allowed here. And this is the condition for the shared lock. Shared lock, it is applicable only for the read operations. If any of the transaction is reading the data, then any number of other transactions can go for the reading data. If any of the other transaction comes for writing purpose, it is not allowed, even though it is the shared lock. Then next we have a exclusive lock. Exclusive lock, it is applied for the write operation. That is update, modification of the database value. In this we have a lock X, it is for the exclusive. Lock yes, it will be indicating the shared lock. So here it will be reading the value A and then it is appending that value with the 50. That is 150 is the A value. It will be writing to the database. So here, when the write operation it is completed, then it will go for the unlock. That when it will be unlocking, then it is free from the lock. Other operations are allowed here. But when the write operation it is performing, no other transaction can come for any of the operation on that particular data value. It is excluded. It is only meant for the writing purpose. This is the main motivation, main idea behind the locking here. That is two types of the locks, shared lock as well as exclusive lock. Basic difference is it is applied for the reading purpose. Shared lock, it will be sharing the same operation with the multiple transactions. That's what the name it is, the shared lock. Only for the read operations, multiple transactions can go for the reading purpose by sharing with the same lock. And then here we have a exclusive lock. Exclusive lock means when any of the transaction it will be performing its action on the particular data with exclusive lock, that data cannot be used with any other transaction for any purpose. No other reading and writing it is allowed in case of the exclusive lock. But whereas in case of the shared lock, no other write operation it is allowed, but read operations are allowed simultaneously. This is the basic idea behind this. Then here we have a compatibility. Same thing what we had explained here in detail with the implementation. The same in shortcut method, we have an identity of these multiple transactions cooperation. It will be shown with the compatibility matrix. So here we have a S is the shared lock, X is the exclusive lock. So when it is a shared, the transaction, it will be reading the data. When T1 it is reading the data and T2 it comes for reading the same data, it is allowed. Then T3 it comes for reading the data, it is allowed. And T4, that like that any number of transactions are allowed. There is a compatibility between S as well as S. But when any of the transaction it is reading the data, if any other transaction, T1 it is reading the A, then T2 comes to write the A, to modify the A, it is not allowed. No other transaction it is allowed to share for the writing purpose. Then like that only here we have a one of the transaction it is allocated with the write operation. Means here it will be having the exclusive lock. Then no other transaction for reading purpose as well as writing purpose it is allowed. This is the basic identity of this compatibility matrix here. The same thing it will be explained here. Then here we have a difference between the shared lock as well as exclusive lock. The basic difference between these two are when it is a shared lock, it is mentioned with the lock S. Suppose any of the data it is taking its parameter, its function as the log S, that is the shared log, that data it is not allowed to take any other write operation, but it can go for any number of read operations. Multiple read operations are allowed here, but write operation, when it is a shared log, other transactions for the shared log it is allowed. But any of the transaction for the exclusive lock it is accepting means it is not allowed here. But whereas in case of the exclusive lock, if any of the transaction it is performing the write operation, then no other transaction for the read as well as write it is allowed. Now here the data value for the T1 it is locked with the exclusive lock, that is A value. That same data value A cannot be used with any other transaction for any purpose. That is the basic difference. This difference only we are mentioned in different dimensions. Lock mode is read only, and here it is only for the write purpose. And shared lock can be replaced on objects that do not have exclusive lock already placed on them. So here we have that all these differences you can notice here, common differences. The basic difference is that one. Shared, multiple shared it is allowed. No any other exclusive it is allowed. Exclusive, no other exclusive and shared it is allowed. That is the basic difference. Then here we have a binary locks. This is one of the basic simple lock, but which it cannot be used and it is having more and more drawbacks because only for one transaction at a time it is allowed. Here we have a binary. Binary in the sense two, that is 0 and 1. Two values here. 1 means the lock will be applied, locked. 0 means it is unlocked. So when any transaction it is entered for the execution, that any data it is allocated with a particular transaction, that it will be locked. Either it may be read or write. That it is locked means no other transaction it is allowed. And when any of the transaction it is unlocked, then that it will be of the 0. Lock equals to 0 means it is unlocked. That data can be used with the other transaction. Here there is no such bifurcation that read operation and write operation. For any of the operation, if once the data it is allocated with any of the transaction, then it will be locked. It will be getting its identity 1. When that data it is having its identity 1 locked, no other transactions are allowed. But this only, this it will be increasing, it will be reducing the throughput of the processor. Because the processor time, it will be wasting lot here. Because when it is a read operation, then also it is showing that it is locked, no other transaction it is allowed. So read operation, it can go for the multiple read in order to improve the efficiency of the processor here. That will be done here in case of the shared as well as exclusive. First basic lock, binary lock it will come. It is very simple here, one transaction at a time. It may be for the read as well as write. No other transaction it is allowed. To improve the efficiency, then it will be going for the shared lock as well as exclusive lock. There we have a read operation will be sharing, write operation cannot be shared. So next here we have a two-phase locking. Two-phase locking, it is one of the technique. That is concurrency control technique, major technique here. In this we have a two-phase. Two means we have a two phases. One is the growing phase, another it is a shrinking phase. So growing phase, what it will show here, that one of the transaction it is performing its operation on the particular data, if it is acquiring the logs. How many logs it is acquired? It may be the shared log or it may be the exclusive log. All the logs it has to get once for all. So that phase, only locking the data items, that it will be coming as a growing phase. How many logs are required? It has to go on locking how many data items are required, that it has to go on locking those data items. That is the growing phase. And for certain point, it has to stop acquiring the logs. That is called as a locked point. Means before this point, all the data are locked here. And from this point onwards, here it will be performing its task. And once the task it is completed, it will goes on releasing the lock here. That is called as a shrinking phase. So how lock it is acquired, in that way it will goes on releasing the lock. Here in this example, we can see here shared lock for the A, then exclusive lock for the B. Then here we have a unlock. How it is coming to unlock? First acquired lock, it will be releasing first. And then next acquired lock, it will be releasing next. In this way, it will goes on releasing the locks here. That is acquiring locks as well as releasing locks. This is called as a two phase. One phase for the growing, another phase for the shrinking here. And in between, it will be performing the operations. So once the data, how many data are required, that all will be locked here, and performance of the operation on that data it will be taking here. And once the operation it is completed, as operation it will be completed with a different data item, it will goes on releasing the lock here. So these are the two phases we can notice. And the same thing in the transaction it is given means T1 it will be, it is required two data items here, A as well as B. It will be locking A, shared lock, and B, exclusive lock. So that how many operations, how many locks are required, it will goes on implementing. And here we have a operations related to those locked data that it will be performing. Now, whatever the operation on this A and B it is required to perform, that it will be performing. And after that point, it will goes on releasing the lock. This is the growing phase, and here it is the shrinking phase. And this one here we have a lock point. Now data are locked, and those data are exclusively meant for the T1 operation to perform the task here. So after by performing that T1 operation, it will be releasing and it will go for the unlock. Like that only we have a T2 also, it will comes. Lock, lock, and after that we have a unlock. In the sequence it will be coming here. So this is how it will be taking the technique of 2PL. The next comes the timestamp ordering protocol. As the name itself it is giving timestamp based on the timing it is. So now here multiple transactions are coming for the execution. T1, T2, T3 and all. N number of transactions it can take. So how transactions are arrived? Like arrival time of the transaction. Now T1 it has come first for the execution, T2 next and T3 next. Like this, which comes older, that in the initial stage that it will be older one, and which comes right now that is the younger. And further T4 it had come means that is the youngest. So older to younger, that is earlier to current transaction it will be taking care. So one of the condition for this, first of all, here we have a timestamp. According to time in increasing order only it will performs the operation. First operation always it will be taking for the T1 and then T2 and then T3. So always the time also it is in the increasing order, and the execution also it is in the increasing order. And one more thing, this timestamp, either it may be the system time, how it is arriving based on that, or it may be of the logical counter. That logical counter, that is 0-1 combination incremental order we can give here. Otherwise, it may be the unique value. In this example, we have taken the unique value 10, 20 as well as 30. Like this, I may take the 100, 200, 300 and all. So here we have a first come, that is first execution, second, third in the increasing order only. Priority of the older transaction is higher. Here we have a ascending order of the transaction creation and executes first. Here we have a older transaction will be executed first because it is having the higher priority. And like that only here we have a last read and last write. Some of the identities we need to take under these concurrent execution of the transactions here. And one thing you have to notice that always the transaction with smaller timestamp And here we have a transaction with a larger timestamp. Means the old transaction to new transaction. Always this direction, it will goes like this. Now you can remember that precedence graph here. In that we have a read or write confliction we are taking here. That is from T1 to T2 it is going means the direction always we are showing like this. And here it is in the arrival time. That is how the timestamps that transactions are coming in the same direction means always it is in the same direction. There is no chance of getting the cycle in the graph because it is in only one direction. So we can confirm it. It is free from the that is conflict serializability. Means there is no confliction among the transactions. It will be ensuring the serializability. The next here we have a in the timestamp ordering protocols functions, we have a three concepts here. Means we will have an idea about these three things. One is the TS TI, that is the timestamp of TI. TI stands for 1, 2, 3. That is T1, T2, T3, that it belongs to the TI here. Indicate timestamp of the transaction TI itself. T1 timestamp 20 and T2 10, 20 as well as 30 respectively, T1, T2, T3. Then now here we have a R timestamp, that is the read. Last read timestamp it is. Last read means now here we have a T1, T2, T3. In this read operation it is there. So later to that T1, is there any read operation? And later to this we have a T3. Means here we have a this read operation is the last operation among all the transactions. Then here we have a RTS, that is the last read timestamp is the timestamp of that particular transaction in which it will be occurring. That is the last read. So here we have a RTS equals to 30 days. Like that only we have a WTS. WTS means that write operation where it has taken at the end. Here we have a write operation in T1 and T2 it will be having, and last write operation it will be occurring in the T2. So here we have a timestamp of the write transaction. It will be of the T2 here. That is T220 it will comes. So write TSA. But it is not like this. In reality, always it will be taking this one and then it will comes to this one. But here to understand this concept, it is given. So here we have a, next we have a timestamp ordering rules. Very important here. So timestamp ordering rules are applicable for the various operations performed on the transaction. Basic two operations as we had discussed here, read operation and write operation. And here we have a different rules for the read as well as write. Suppose whenever the transaction TI issued a write read operation on the particular data value X. Now we'll be considering the X data value. Upon that read operation, the transaction it will be issuing for the read operation. It is performing the read operation. Then when it comes for the read operation, it will be checking for the write condition. Look here, when it is a read, shared lock it will takes and other read operations are allowed. No any confliction with the other read operation, only confliction with the write operation. That's what here the condition will be checked against the write operation. So read X, here we have a write timestamp of A, which is greater than timestamp of TI. So this we have to compare with the example. Now here in which of the transaction write operation it will be the last. Here there is no write operation. Here in T2 it will be having the last write. That's what write timestamp. It will be having 20. In which transaction that we have to notice. Now this value it is the 20. 20 is greater than timestamp TI. Timestamp TI means now first time that transaction T1 it will be coming and then T2 it will comes. So first TI value it is a T1. What is the timestamp of this one means it is the 10. So here we have a 20 is greater than 10. So when this condition it is true, it has to roll back. It is not allowed to execute. Why it is not allowed to execute means always the execution in the series of the timestamp. How that arrival of the transaction it will be coming according to that time it will take the execution. Now in this example, the T1 it will be arriving, but no any transaction it will be that any operation it is taken. Directly it goes to the T2. So from T2 it is started. T2 to next further it will go for doing the further operations, but it cannot go back to this one. So here the database value initially it may be 30 here, and 30 it will go for the fail, that is the rollback. Again next it may go for 40, again it may go for 50 and all. It will be ignoring this one because it cannot be considered. After performing this operation only, this operation it will takes. But here no operation in the first, the T1. Directly it had come to the T2. Then it will goes to the further T3, T4 and all higher time stamp order it will be taking. It cannot go to the previous one, that rollback. It cannot be considered. Any of the value in the T1 is not considered. That's what it is not allowed. This is the read. This is the rule for the read operation. It will be checking against the write. So now what is the solution for this? Then here we have a otherwise, either we have to go for the rollback, otherwise we have to implement the solution. What is the solution? We have to interchange. Here we have a write operation to the T1 it is given, and after that it can go for the reading. After that it can go for the further transaction. That it is allowed because here we have a direction always it is in the right side. Precedence graph it will be taking from T1 to T2, T2 to T3 and T4, T5, how it is coming in the same sequence it will be taking here. So this it is allowed. So what we have to do in order to interchange this T1 and T2, here is the formula. Set R TSA, that is a read timestamp of A equals to maximum we have to take. That is the last in the sense maximum of read timestamp of A and timestamp of TI. Among these two, which is the maximum? 20. 20 we are applying for the read here, and then write automatically it will comes in the first position T1, and after that T2 it will comes. This is the first timestamp ordering rule. The next here we have a timestamp ordering rule for the write. If the transaction is coming for the write operation, writing on the X data value, then write operation it is having the confliction with the other read as well as write. No other transaction for reading and writing it is allowed. So here it will be checking its confliction against the read operation as well as write operation here. So now here we have a read timestamp of A. Now we can consider this example. Now read timestamp of the A means last read operation where it is taken in the T2. What is the timestamp value? That is the 20. 20 is greater than timestamp of TI. Timestamp of TI means this one here, the 10. So 20 is greater than 10. It is not allowed. Roll back. It is not allowed because T1, still it is not started any of the transaction. Directly it is started with the T2, that is the read. Read operation it is taken from the database. But here we have a database value from where it will come, say equals to 20, it is unidentified because it is the nil. Nothing is there. Again, it is not considering the previous operation. Updates will be in this direction. So it is not allowed. So this read A, I'll be replacing with the write WA. Then also the same problem here, that it will be given here. Now here we have a write timestamp of the second condition. It will be checking for the other write operation. That is, here we have a write A. A equals to 10 it is. And this is write timestamp of the A. Write timestamp of the A. How much here? That it will be of the 20 itself. Now here it is 20. 20 means in the same example, this it is replaced with the write operation. Now it is the 20. 20 is greater than write timestamp of the timestamp of TI. Then here we have a once again we have a timestamp of the TI. It is the 10. 20 is greater than 10 for the write also. Then it is not allowed. Roll back. So otherwise what we have to do? Here we either we have to roll back and it is required to cancel that operation. Otherwise, here the solution is set write timestamp of A equals to last TS TI. Means T1, T2 and all it is there, which is the maximum that should be applied for the write operation. So here also we have a write operation, it is last, and write operation, it will be last. Means one thing you need to remember here, if the execution is not started with the first slot of the T1, then directly it cannot go to T2. Once it goes to T2 means whatever the operation it is performed in the previous transaction, it can be ignored. It cannot be considered. So it leads to the inconsistency here. That's what here always the execution, it will be in the sequence of the order, how the transactions are coming with respect to their timestamp. Always in the ascending order it is execution. Look here. Now if I go for the graph, here the direction I'll be showing from R of A to W of A, that is T1 to T2. I cannot show that direction to the T1 once again. If I show that one means the cycle formation. Once the cycle is formed, it cannot ensure the serializability. That is the condition here. But always the timestamp ordering, the timestamp concurrency control, it will ensures the serializability. That is the main objective. I hope it is clear to you. Here it is a read operation and it will be checking against the write condition. When it is the write operation, the TI it is performing write operation, then it will check for the other read as well as write, both. Then here we have a advantages. It is very important. Here we have a timestamp serialize, that timestamp, it will be maintaining the serializability of the protocols. It will maintain the serializability and it will be free from the deadlock also. And here we have a conflicting pairs is not there. No conflicting pairs at all. But here we have a disadvantage. It is not recoverable or free of cascade. Look here, not recoverable. Why it is not recoverable? Suppose now T1 it is performing the task and here it will comes and before committing now it will comes to the initial state and it will be cancelling all the operation. But it cannot be affected with this one. So this it will remains as it is. That's what here it will be no recoverability. That is these are the main properties of the timestamp order here. Then next comes multiple granularity. It is very important and very simple also. Here we have a multiple granularity is nothing but a size of the data. That data may be individual record or it may be the file or it may be some area, database area or the complete database. So these are that all are represented with the granularity here. So here we have a fine granularity as well as coarse granularity. These files, records and databases will be arranging in the tree structure, that is a hierarchical structure. Here you can notice now this is a database and in database we'll be creating some other sub databases and within the sub databases we have a files here and within the files we have a records. So it will be arranging in the hierarchical form. And this one it is called as a fine granularity. Here we have a fine as well as coarse granularity. Fine granularity is this one. Here we have a leaf, means last records what we are taking, that it is fine here, and which is having in the highest position, that is called as a coarse granularity. Here we have a lower in tree is the fine. As it is the lower, there we have a multiple files and multiple operations it will be performing because records are considered and more content and more here we have a concurrency related problem. So high concurrency, high locking overhead in case of the fine granularity. Like that only, coarse granularity, it will be low locking overhead and low concurrency because here in order to take the concurrency, only one database it is there. Here we have only two areas are there. As it goes below, here we have a multiple contents. When the data, data will be more, that more locking it is required and more concurrency it is required. So at a time it is working with the one database, two areas, four files, and here we have a number of records. So that always here we have a lock. When we are applying the lock here, If it is required to apply the lock for this data, it is required to take lock from here. Always the condition is, if I need one of the lock for this particular data item, then it has to come by applying the lock from here. A certain intention locks it will be applying, then it will go for the particular lock here. So here we have a granularity is nothing but size of these data items here, and those will be arranged in the hierarchical mode. Applying lock always it will comes from the that coarse level, that is fine coarse granularity to fine granularity. It will be taking the applying lock. So lock, if it is acquiring the lock, that ascent will be given from here to here and here to here and here to here. If anyone it is refused to take that particular lock, it is not allowed to apply the lock for this one. This is how locking it is from top to bottom. And unlock always it is from that bottom level to that of the top level. That is fine to course it will be taking here. Then now here we have a already we had discussed with two types of the locks here in 2PL, that is the exclusive as well as shared lock. Along with these exclusive and shared lock, we have a three more extra locks are coming in the granularity. Intention shared, intention exclusive, shared and intention exclusive. We have a three types of the locks. To understand this, it is very simple here. Now here we have a one of the transaction T1. It is executed, it is executing and it is applied with the intention lock here, intention shared. So when it is having the intention shared, then here we have a other transaction. It is coming for the intention shared, then it is allowed. Another transaction, it is coming for intention exclusive lock, then it is allowed. Then shared lock and SIX, all it is allowed, but only the exclusive. T1, it is allocated with the IS. T2, it is acquiring, it will be requesting for the IS of the same data. Data item X, it is allocated with the T1 in IS mode. Then another transaction, it will be asking that X in the IS mode. X, it will be asked for the IX mode. And X, it is asked for the S mode. X, it is asked for the SIX mode. Means when any of the data item, now you can notice here, suppose now one of the data item, it is occupied with the IS, that is the intention shared lock. Then any other transaction, one transaction it is allocated T1, T2 it will comes and ask for the IS, it is allowed here. T2 it will comes and ask for the IX, it is allowed. Yes, SIX means shared lock, intention exclusive lock and intention shared lock, as well as shared and intention exclusive lock, it is allowed. But exclusive lock it is not allowed. If any other transaction, T2, it will comes and it will be asking for the exclusive, which already allocated with the IS. It is not allowed. Like that, here we have a IX. Now, any of the node, now we can consider this node, already it is allocated with the IX. Means in this area, one of the transaction is occupied with the IX, intention exclusive mode. Then any other transaction comes and it will be asking the same area for the IX, IS, it is allowed, IX, it is allowed, but shared SIX and X, that no other transaction for the shared operation and shared intention exclusive operation and exclusive operations are not allowed here. Only these two, that is, it is allocated, one of the transaction is allocated with the IX, then other transaction can come for the IS as well as IX, but no other operations are allowed here. In the similar way, we have a exclusive lock. When any of the node it is allocated with the exclusive lock, no other type of the lock it is allowed. Means no any other transaction for any type of the lock it is entertained here. So this is the main objective of this granularity here. Means this table, it will be showing the compatibility between the different types of the locks. Then now here we have one of the example we can notice. In this, we have a DB, A1, FA, and all. So for this particular record, here we have an example. T1 reads R, that is A2. Here, record A2, it will be reading by the transaction T1. Then this read operation, read means here shared lock it is required. That shared lock, how it will comes? Always the applying lock, it will be coming from the database. That is, here we have a course to find it will be coming. That is first, it will be having here. First, it is required to take IS, because here shared it is required means that intensive shared it will be taking. Respective intensive operation, it will takes here. So here we have a that T1, it has to put IS for this. And then here also it is having the IS, it is required to take the IS, intensive shared. And then here also intensive shared. Then this intensive shared, it is allowed to take the shared operation here. It is allowed here. Here it is required shared. So shared operation, it will be compatible with the intensive share. That's what from here it will take the intensive share and share operation it will be taking. So already it is allocated with the shared lock, and these are allocated with the intensive shared. Then next here we have a T2, one more transaction. It will ask for the writing purpose, modification. Modification of this A2, second record modification. Already it is in the shared mode. It is acquiring the shared lock, and for the same it is asking for the write operation here. So that is the exclusive lock. So exclusive lock, how it will comes? Intensive exclusive it has to take for the previous. From there it will be having the internet, that is exclusive lock. So first it is required to start its acquiring lock from the DB here. DB already allocated with the intensive shared lock. Then now it is asking for the intensive exclusive lock, intensive exclusive lock. So now already it is having IS and IX it is allowed. Then compatible it is. Then it will take IS, IX, and this one also it is taking IS, IX, and this one also it is taking intensive shared as well as intensive exclusive lock. Then here when it comes to this one, already here we have a shared lock. When it is having the shared lock, no other exclusive lock it is allowed. So this operation, it is not allowed. This transaction, T2 cannot be accepted by the transaction, that execution here. Then comes next one, T3 reads all the records on FA. So now FA, already it is having the intensive shared and intensive uh, exclusives. That is intentions shared and intention exclusive lock it is having. IS and IX it is having. And one more transaction, T3 it is coming and asking for the read, that is shared operation. Record reads. Read operation means it is asking for the shared. So now we have to check here. Now it is asking the shared. When it is the intensive shared, it is compatible with the shared. But when it is the intensive exclusive, it is not allowed. So here it is not compatible. That's what this transaction, that T3 also not accepted here. It is failed, because already it is having IX as well as IS. Only it was having IS means it would have taken shared, but it is having IX also. That's what no other shared operation it is allowed for this one. And then finally here we have a one more example. T4 reads entire database. Now T4 it is required to read the DB, that is the database. Database already having IS and IX. Both it is having here, both the logs. Then what about this shared log? So shared log, it is having IS. Okay, it is allowed here. But IX also it is having, it is not allowed. This it is incompatible. That's what this operation also, it is not entertained. So this is how it will go for acquiring the lock as well as releasing the lock. It will comes from the bottom to top. So when it is required for any of the node, that is the shared, then it has to come from here by using the IS, intention shared. When it is required for any of the transaction that is exclusive, then it has to come by taking the intention exclusive from here to till exclusive. This is the way how it will be applying the block for these granularities. So multiple granularity, how it is working, what I had explained, based on that we have some statements here. This is how we can go for the different types of the concurrency control techniques, which are very important. That I hope it is clear to you, and thank you for watching.